Aswani, Assistant Professor, Department of AIML at MLR Institute of Technology. Welcome back to another session of Artificial Intelligence. In this session, we will see how the CNN will work. With the example, we will see how it will be work, how it will be classify the images. So the overview is example of working CNN step-by-step procedure. Okay, let's see how it will work. Already we know the convolution neural networks, how many layers are there, how it will be performed. We'll see. The first layer is input layer. Next one is convolution layer. In the input layer, it only will take the raw image with to find the patterns, to know the features, and to classify that image. And next, the next layer is convolution layer. This is the one of the important layer which is used to extract the important features of that image. Next one is rectified linear unit layer, that is the activation layer. After that, pooling layer, max pooling will be applied. The next one is fully connected layer. We'll see the step by step. Okay, let's understand the example here. Here, this is the X, and applying the CNN and identifying this is an X. And same, this is O, applying CNN and identifying this is an O. Okay, let's understand. So if you represent X in any way, means generally the system knows when we give only this X, then it will categorize the X. Okay, for example, if you are giving this X to computer and you are asking to identify what this letter is, then what it will do, it will take the pixels of that letter. By using that pixels, it will identify whether it is a X or it is not a X. In the same way, whether it is a O, it will consider the pixels of this image. Wherever the letter is appeared in that location, it will take the pixels. It will match that pixels with the already trained models pixels. Then it will identify whether it is a O or not a O. For example, what happens when we give the X in a different way, like this or like this, with some noise or incomplete data, whether computer is able to identify whether the X is a X or not, or O is a O or not. Sometimes the children, or some of them, will write like this or like this or like this. The different people will represent O in the different forms, deformed, destroyed form. So, in such scenarios, computer unable to identify that image. But whereas CNN will classify that image. Let's see how. Okay, X can represent in this 4 forms like this. Okay. X original in this way, means sometimes it will be reduced, sometimes it will be increased, sometimes it will start from the corner, sometimes it will be some another curve shape, or also in the different forms. Whether it is X in the smaller one or it is in the starting from the corner one, it has to be identified as X, but computer is unable to identify this because whatever we trained, that is pixels of this line, but here it is starting from here, so it is failed to recognize this X or this O. Okay, so here 4 forms as well as the right side. So these are nothing but the effects of the deformed images, some noise. Here there are multiple presentations of X and O. This makes it tricky for the computer to recognize. But the goal is that if the input signal looks like previous image, whatever we trained that model, it has seen before, the image reference signal will be convolved with that input signal. The resulting output signal is then passed to the next layer. Okay. So let's see, these are the noisy images. Even though if it is noise, the CNN is able to classify the exact matching image. Let's see, a computer understands an image using numbers at each pixel. So here the blue lines are image pixels of X. In our example, we have considered that a blue pixel will have value 1 and a white pixel will have -1 value. This is the way we have implemented to differentiate the pixels in a primary binary classification. When we use standard techniques to compare these two images, one is a proper image X and another is a distorted image of X. We found that computer is not able to classify deformed image of X. It is comparing with the proper representation of X. So when we add the pixel values of both of these images, we get something. So a computer not able to recognize whether it is an X or not. So the computer failed to recognize this image. So then how it will be recognized that pattern, that image as X or O? Then with the help of CNN, we make a small patches of our image and we will compare that small patches with the original image and it will identify. Let's see. Take small patches of our image. So these P's or patches are known as filters or kernels. We were finding rough feature matches in the same position into two pictures. CNN gets better with the similarity between whole image matching schemes. We have these filters. So consider this first filter. This is precisely equal to the feature of the part of the image in the deformed image as well as the proper image. So CNN compare the piece of the image by the section. It will slides over entire image with that small patch. By finding rough matches in roughly the same position in two images, CNN gets a lot better seeing similarity whole image matching schemes. Okay, let's see how it will be. Let's look at this one. It will take the small patches and it will be slides over these values. Okay, so we have three features or filters as shown below. This one, the colors of differentiating, this one and green and red also. Okay, here we are taking three filters, multiplying the corresponding pixel value. First take the first filter and slide over entire image. Then 1 into 1 plus -1 into -1 in such a way, multiplying and summing entire region. Then we'll get the 1. The next -1 into 1. Again we'll get the 1. So after adding and then divide the multiple total number of pixels. So here we'll get the 1 value. So total 9 numbers, 9 will get after multiplying and adding, will get 9 values divided by 9. Okay, so creating a map to put the value of the filter at the place wherever the region. Here we will get the 1. So we'll place the 1 value there. In the next one, we'll get the 0.55 after adding and multiplying. So after convolution layer, the output will be look like this. After performing after slide overing and the entire image with the filter or kernel. So similarly, we perform the same convolution with every filter. So after this, we'll get the feature maps like this. The next layer is rectified linear unit layer, means activation. In this layer, we remove every negative value from the filtered image. So RELU formula is max of 0. If it is a maximum value, then will remains the same. If it is a negative value, will enter into the 0. It is happening to avoid the values adding up to 0. Rectified linear unit transform function only activates a node if the input is above certain quantity, while the data is below 0, the output is 0. But when the information rises above threshold, it has linear relationship with the dependent variable. Let's see how it will be. 0, if x less than 0, then it will be 0. If it is a negative value, that is 0. If it is a positive value, the output is positive value. Let's see, -3. The output of RELU is 0. Plus 3, the output is 3. Okay, removing the negative values. 0.77, then it remains the same, minus 0.11, then it will be 0. Let's look at after performing RELU, the feature map is look like this, zeros and positive values. Okay, so to all the feature maps, it will apply the RELU activation function. The next one is pooling layer. Already we have seen in the previous session, we shrink the image stack into smaller size to model effectively. Pooling is done after passing by the activation layer. We do by implementing the following 4 steps. Pick a window size of 2 or 3. Pick a stride 2. Walk your window across your filtered images. From each window, take the maximum value, applying the max pooling. Let us understand this with an example. Okay, the first one. Which one is the highest value? 1. So 1 will be taken. And again we'll go to the next one. Which one is the highest value? 0.77. We'll take the 0.77 value. In such a way, after completion, entire image will get this output. Okay, to entire feature maps. Next, stacking up the layer, so that get the time frame in one picture we here with 4x4 matrix from a 7x7. In the feature of map, we will have the 7x7, then we reached with the 4x4. Like this, first we applied the convolution, later activation, after that pooling to shrink the size. So here, this is how on the multiple times we need to apply the same. Okay, we reduce the image from 4x4 to something lesser. We need to perform 3 operations in the iteration after first pass again. So after second pass, we arrived at a 2x2 matrix as shown below like this. First convolution layer, the big one, RELU pooling. After that, again you want to reach the smaller size matrices, then we have to apply once again convolution activation and pooling. Then we will reach with the 2x2 matrix. The last layer in the network is fully connected or dense layer, meaning that neurons of preceding layers are connected to every neuron in subsequent layers. So each neuron, each patch will be attached with another one, connected with another one. Later it will be identifies whether it is a ear or it is a eye of cat, like that. This mimics high-level reasoning where all possible paths from the input to output are considered. Then take the shrunk image and put into the single list. So we have got, after passing through 2 layers of convolution, RELU and pooling, and then converting it into a single vector or a vector. Single file array vector, we take the first value 1 and then we retake 0.55, we take 0.55, then we retake 1, then we take 1, then means whatever values are there, these values. Okay, we'll take those values to identify whether it is a X or O. Okay, let's see the output layer. When we fed X and O, then there will be some elements in a vector that will be high. Whatever high values will be there, we'll consider those values. Consider the image below. As we can see, for X, there are different top elements, and similarly O also. There are specific values in the list which were high, and we repeat the entire process which we have discussed for the different individual costs, which will be higher. So for X, we have first, 4th, 5th, 10th and 11th element of vector values are higher. For O also, 2nd, 3rd, 9th, 12th elements, means in the circular way. And these X values are the like this, vector higher. We know now, if you have an input image with the first, 4th, 5th, 10th and 11th element vector values high, we can classify X. Similarly, if our input image has a list which has the 2nd, 3rd, 9th, 12th element, then it is like this, X and O, whatever the first position, 5th position, like that, the highest elements contains in that position, then it will be classified as X. And the 2nd, 3rd and these positions having highest values, then that will be classified into O. So in this session, we have seen how the working of CNN, The example is classifying X and O, with the example how it will be classified, how it will be applied convolution layer, how the RELU applied, how pooling layer is applied, what are the pixel values has been taken to identify the X and O.